The dream of driving a rebuilt Bugatti Veyron was finally within reach, but one unexpected problem threatened to ruin everything. After spending months rebuilding one of the world's most famous hypercars without help from Bugatti, the team believed they were only moments away from enjoying the reward for all their hard work. However, during the first test drive, they noticed something was wrong. The engine was making power, but the car struggled to move forward smoothly. Instead of gripping properly, the newly installed clutch was slipping. Every time the accelerator was pressed, the engine's speed climbed much faster than the car's speed, showing that power was being lost before it could reach the wheels. This was a frustrating discovery because replacing the clutch had been one of the biggest jobs during the rebuild. If the problem could not be solved, the entire rear section of the Bugatti would need to be taken apart again. That would mean removing the gearbox, opening everything once more, and possibly starting over after 6 months of careful work. Rather than rushing into another expensive repair, the team decided to understand exactly what had gone wrong. They invited Rob Barnes, one of the engineers who had helped design the Bugatti Veyron's gearbox and clutch system many years ago. His experience could provide answers that nobody else could. After examining the car and watching how it behaved, Rob confirmed that the clutch was definitely slipping. However, the reason was more complicated than simply installing a bad part. Since Bugatti had refused to sell an original replacement clutch, the team had no choice but to build their own using modern materials. Although the new clutch looked almost identical to the original, small differences in the friction material and surface design could completely change how it behaved inside the gearbox. What seemed like a simple replacement had actually created a challenge involving engineering, software, and mechanical design. Instead of giving up, everyone became even more determined to solve the mystery and prove that rebuilding Bugatti outside the factory was still possible. As Rob studied both the original Bugatti clutch and the newly made replacement, he discovered several important differences that explained why the system was struggling. Even though the new clutch had been carefully reverse engineered, the friction material was not exactly the same as the factory version. The original clutch used a special material and surface pattern that had been developed after years of testing, while the replacement used a newer carbon-based material that worked well in many modern dual-clutch gearboxes. The problem was that the Bugatti Veyron was never designed to use this newer material. Rob explained that the original clutch contained special grooves and cutouts that allowed a huge amount of oil to flow through the clutch plates. This oil was necessary because the Veyron produces incredible power, creating massive amounts of heat that must be removed quickly. However, the same oil that cooled the clutch could also reduce its grip if it was not managed correctly. To make this easy to understand, Rob compared it to driving a sports car on wet roads. A tire with the right tread pattern pushes water away and keeps touching the road. But if too much water stays underneath the tire, it begins to hydroplane and loses grip. The Bugatti's clutch was experiencing a similar problem. Instead of making solid contact, a thin layer of oil stayed between the clutch plates, making them slide against each other rather than lock together. This caused the engine's speed to rise, while the car struggled to accelerate properly. The team now understood that the clutch itself was not completely faulty. Instead, the combination of different materials, oil flow, and software settings created conditions that prevented the clutch from working as intended. Rob suggested that one solution would be to remove everything again and redesign the clutch with a second version that copied the factory design more closely. However, that would require splitting the entire car apart once again, something nobody wanted to do unless absolutely necessary. Fortunately, Rob believed there was still another possibility. Hidden inside the Bugatti's advanced gearbox software was a self-learning system that might be able to adapt to the new clutch over time, offering one final chance to save months of hard work without taking the car apart again. The idea that the Bugatti could teach itself to work with the new clutch sounded almost unbelievable, but Rob explained that this was one of the clever features built into the car when it was first designed. More than 20 years ago, the engineers knew that every clutch would work differently over time. Instead of expecting every clutch to behave exactly the same forever, they programmed the gearbox to constantly monitor its own performance and make small adjustments whenever necessary. This self-learning process was known as clutch adaptation. The problem was that the system only worked under very specific conditions. First, the transmission had to reach a certain operating temperature before the learning process could begin. Then the driver had to leave the car completely alone for a short time, so the gearbox could perform its own checks without any interference. As the transmission warmed up, everyone gathered around the diagnostic equipment, watching the live data with great excitement. Once the correct temperature was reached, they waited quietly. After several tense moments, the computer showed signs that the gearbox had finally started its learning cycle. The clutch slowly opened and closed by itself while the software measured how much pressure was needed to create the perfect engagement point. It was almost as if the car had come alive and was quietly teaching itself how to use its new parts. Matt could hardly believe that engineers had built such advanced technology into a production car so many years ago. Every movement of the clutch was controlled automatically without anyone touching controls. Rob explained that this was only the first step. The gearbox could learn a few basic settings while standing still, but the more important adjustments would only happen while the car was actually being driven. During normal driving, the computer would continue collecting information, comparing engine speed, clutch pressure, and many other measurements. Little by little, it would change its settings until the new clutch behaved as closely as possible to the original factory part. Although nobody could guarantee that the process would fully solve the problem, it offered real hope. Instead of tearing the Bugatti apart immediately, they now had one last opportunity to let the car's own intelligence complete the job that month of engineering had started. With fresh hope, the team prepared for the next stage of the test. Although the gearbox had completed its first learning process, while the car was standing still, everyone knew the real challenge would begin once the Bugatti was back on the road. Rob explained that the transmission could only finish adapting by driving at steady speeds in different gears for long periods. During those moments, the gearbox would carefully study how the clutch behaved under real driving conditions and slowly improve its settings. To reduce the risk of damaging the clutch, Matt decided not to drive the car himself at first. Instead, Rob and another experienced engineer took the driver's seat because they knew exactly how a healthy Veyron should feel. Their job was to gently accelerate, maintain constant engine speeds, and avoid sudden throttle movements that could overheat the clutch before it had a chance to adapt. As the Bugatti pulled away, everyone immediately noticed something encouraging. The clutch already felt smoother than before, and the car crept forward more naturally. It was a small improvement, but it proved that the learning process had already begun. Unfortunately, another problem soon appeared. Heavy traffic made it almost impossible to keep a steady speed for the required 30 seconds. Every few moments they had to slow down, stop, or change speed because of other vehicles on the road. Each interruption prevented the gearbox from completing another part of its learning cycle. The engineers quickly realized that continuing under these conditions could do more harm than good. If the clutch kept slipping without completing its adaptation, it might overheat and become damaged all over again. Rather than taking unnecessary risks, they made the difficult decision to stop the test and return to the workshop. Although it felt disappointing, everyone agreed it was the smartest choice. Instead of forcing the process, they planned a better strategy. They would wait until late at night, when the roads were almost empty, with little traffic and long stretches of open road. The Bugatti would finally have the perfect conditions to complete the learning process without constant interruptions. It meant waiting a little longer, but after 6 months of rebuilding the world's most famous hypercar, one more night of patience seemed like a very small price to pay. Late on Sunday night, when most people were asleep and the roads were almost empty, the team returned with one clear goal. This was their best opportunity to let the Bugatti finish teaching itself how to work with the new clutch. Unlike the earlier test, there would be no heavy traffic to interrupt the learning process. The driver carefully followed Rob's instructions, holding the car at steady speeds and constant engine revolutions for around 30 seconds at a time. They repeated the same routine in different gears and at different engine speeds, giving the gearbox as much information as possible. Every smooth run allowed the transmission computer to collect new data, compare it with its previous settings, and make tiny adjustments. It was a slow process that required patience, but after about 40 minutes something exciting began to happen. The clutch started feeling much stronger and smoother than before. Gear changes became cleaner. The slipping almost disappeared, and the car pulled away with far more confidence. For the first time since the rebuild, everyone felt that they were moving in the right direction. However, the night was not completely free of problems. During the testing, the Bugatti suddenly entered limp mode, reducing its power to only a fraction of what the engine could normally produce. While this might have sounded like bad news, it actually helped during the adaptation process because the lower power made it easier to keep the car at steady speeds without putting extra stress on the clutch. Instead of worrying, the team focused on completing the learning cycle. By the time they returned to the workshop, the gearbox felt almost completely transformed. The following day, Rob and the other engineers took the car out once more to compare its behavior with the earlier tests. Their verdict was extremely encouraging. Although they admitted the clutch was not yet absolutely perfect, it was dramatically better than before. The slipping had almost disappeared, gear changes felt natural, and the transmission behaved much closer to how a factory Bugatti should. Months of uncertainty were finally beginning to turn into confidence. Rather than taking the entire car apart again, they had proven that the Veyron's advanced engineering could adapt to modern components, saving countless hours of work and bringing the dream of driving the rebuilt hypercar much closer to reality. With the clutch finally behaving much better, the team could now turn their attention to several smaller problems that still prevented the Bugatti from being considered fully finished. While the biggest mechanical challenge appeared to be under control, the car still had a few electrical and cosmetic issues that needed to be solved before anyone could confidently call the rebuild complete. One strange problem involved the door locks. During one of the earlier test drives, the Bugatti had unexpectedly locked itself, and neither the remote key nor the door handles could unlock it. At first, everyone feared that an expensive electronic component had failed. Since Bugatti parts are famously expensive and often difficult to obtain, replacing the locking system was the last thing anyone wanted to do. Instead of ordering new parts immediately, the team carefully removed the door mechanism to understand exactly what had happened. After taking everything apart, they discovered that the lock itself was not broken. The real issue was a small amount of extra tension in the cable connecting the door handle to the locking mechanism. After making a simple adjustment and applying fresh grease to the moving parts, the door began working normally again. It was a perfect example of how careful diagnosis could save thousands of pounds by fixing a small problem instead of replacing an entire assembly. The rear wing also needed attention because it had stopped communicating with the car's electronic control system. Until a permanent repair could be found, the team created a temporary solution using specially designed nylon supports to hold the wing in the correct position. Finally, they investigated why the engine was still entering limp mode and limiting the car's power. After studying live sensor data instead of relying on fault codes, they noticed unusual airflow readings from one side of the engine. The replacement airflow sensors installed earlier were not genuine factory specification units, so they decided to replace them with the correct original Bosch sensors that matched Bugatti's requirements. Once those sensors were installed, the engine readings became much more balanced, giving everyone confidence that they were finally solving the last remaining issues. One by one, each small victory brought the rebuilt Veyron closer to become the fully functioning hypercar they had dreamed of driving since the project first began. After months of hard work, endless repairs, and countless unexpected setbacks, the moment everyone had been waiting for had finally arrived. With the major mechanical problems solved and the remaining small issues under control, it was finally time for the owner to drive the Bugatti Veyron himself. This was far more than just another test drive. It was a reward for 6 months of determination, problem-solving, and refusing to give up when many people believed the project would fail. As he climbed into the driver's seat, the excitement was impossible to hide. Years earlier, he had admired the Bugatti Veyron as one of the greatest cars ever built, never imagining that one day he would own one, let alone rebuild it almost entirely from scratch. The engine came to life, and as the car gently pulled away, the first thing everyone noticed was how smooth everything felt. The clutch engaged naturally, the gearbox shifted cleanly, and the car behaved exactly as a Bugatti should. Even at low speeds, the Veyron felt solid, comfortable, and surprisingly easy to drive. There were no worrying noises, no sudden warning lights, and no signs that months earlier the car had been sitting in pieces with a damaged gearbox. The emotional weight of the journey began to sink in. Every frustrating setback, every late night in the workshop, and every difficult decision had finally led to this unforgettable moment. The team members watching from the passenger seat could immediately tell how much progress had been made. They confirmed that the clutch now felt almost identical to a properly functioning factory system, proving that the gearbox's self-learning software had successfully adapted to the new clutch material. For everyone involved, this was not simply a successful repair. It was proof that patience, expert knowledge, teamwork, and careful engineering could overcome challenges that many believed were impossible outside the Bugatti factory. The first proper drive marked the end of one chapter and the beginning of another. Instead of worrying about whether the Veyron would ever work again, the team could finally look forward to enjoying the car, taking it to events, and showing the world that one of the most complicated hypercars ever built could be brought back to life through determination and skill. Although successfully driving the rebuilt Bugatti Veyron was already a huge achievement, there was still one final question that everyone wanted answered. Had this ambitious project actually been worth the money? To find out, the owner invited several respected hypercar specialists to inspect the finished car and give their honest opinion about its value. These experts had years of experience buying and selling some of the world's rarest performance cars, making their opinions extremely important. As they walked around the Veyron, they were impressed by the quality of the rebuild. They praised the attention to detail, the condition of the car, and the fact that every important part had been carefully repaired or restored instead of simply being replaced. They also explained that the market for Bugatti Veyrons had become much stronger in recent years. As these cars celebrated their